Let's talk about continuous functions. There are two ways to tell if a function is continuous. There's a real definition and a more simple definition. Starting with the simple definition. If I can draw a function without lifting up my pencil, then it's said to be continuous, such as this red line here. If I have to lift up my pencil, it's not continuous, such as this graph here. Something like a hole or an asymptote, or in this case, a jump, would make a graph discontinuous. Now, I had one student one time when I told her this, and she said, but I can draw a hole without lifting my pencil. She went, please no, that does not count. A hole is discontinuous. Now let's say you want the more formal definition. So a formal definition of continuous functions would be f is continuous at a if and only if the limit as x approaches a of f of a equals f of a. This is taking what we have been doing in calculus with limits and putting it together with algebra. If you saw my previous video on limits, then you kind of know what we're talking about here. If, for example, I'm looking at this red function, and I want to find, is it continuous at this point A here? I want to say, if I cover up this point here, and I say, what is the limit? And it looks like the limit as x approaches a of f of a equals some y value. And then I uncover that line, and it turns out the algebraic definition of f of a equals y. Because these are the same y, then I know the function is continuous at y.